Here's some questions from the linear equation section 1.5. This first one you need to solve for x. It seems a little funny, this one. Like the numbers are the same on both. Oh, the 11s aren't the same. Anyway, let's take a look at it. So I could deal with fractions first, or I could deal with just move things around. Maybe I'll just move things around a little bit. So let's add 4x to this side. If I do it there, I need to add 4x to this side. When I do it, these ones cancels, but then these ones cancel too. Oh, interesting. So what I would come up with is an answer that says 2/11 is equal to 9/11. But is that a true statement? It's not true, right? So this is false. These aren't equal to each other. And so if you have something like that where the x's like this cancel out and you come up with a false statement like this, then you would say no solution. In other words, there's no values of x that you could put in there that would make that statement true. Now, if you have an equation like this where everything cancels out, basically, or if you come up with a true statement like 4/7 is equal to 4/7, if you come up with a true statement, then what your answer would be all real numbers are a solution. So all real numbers would work. So a question like this, if I said 2x is equal to 2x, you could plug any number you want in for x and it would be true. Therefore, all real numbers are a solution. That's that one. Here's another question where we have to solve for x. So first off, I would get rid of the brackets. So I'd use the distributive property to multiply that through. Notice on the second one, it has to be -5 times each of those. So let's do the first one. So that'd be 2x, 2 times -4 is a -8, equals 3. -5 times 2x is a -10x. -5 times a +1 is a -5. Let's collect like terms on the right side there. So I'd have -10x, and 3 take away 5 is a -2. Now let's move all the x's to the left-hand side. So I'm going to add 10x to this side. If I do it, I have to add it to this side. So I'd have 12x minus 8 is equal to a -2. And then we'll add 8 to both sides. So I'd come up with 12x is equal to 6. And then divide both sides by 12. And I'd come up with x is equal to 1/2. Okay? And then at the end, it's not a bad idea to take that and plug it back into the original equation where you see both those x's and see if the answer is correct. Okay, another question. So it's a linear equation again, but it is a worded one. So I've got a freight train, leaves a station, goes north, and it goes for 60 goes at 60 miles an hour. And then an hour later, an Amtrak passenger, and it goes the same direction, but it's going faster. And then they say, how long will it take the passenger train to catch up to the freight train? So to do this, I like to use that distance equals rate times time. And I'm going to find out that information about both the freight train and the passenger train. So the distance, I don't know what the distance is for either of them, but I know the freight train is going 60 miles an hour, and I know the other one's going 80. Then the relationship between the time, I could say that we want to know how long it'll take the passenger train to overtake the freight train. So let's say this is t, and then for the freight train, they have an extra hour. So I would call this one t plus 1. Okay, now I know the formula is d equals r times t. So for the freight train, it'd be d is equal to 60 times t plus 1. And for the passenger train, it'd be d is equal to 80 times t. But we want to know when the passenger train catches up to the freight train. So that would be that d is equal to d. So if those two are the same, then I can say this is equal to that. So 60 times t plus 1 is equal to 80 times t. Now use the distributive property, 60t plus 60 is equal to 80t. Now I'll get the t's together. So subtract 60t on both sides. So I'll have 60 is equal to, that would be 20t. And now we'll divide both sides by 20. So t is equal to 3. Now some people in this question, I think this is correct, some people in this question, for the time, rather than putting the t plus 1 here and a t there, they put a t on this one, and then this one is 1 hour less. You could use those too, but just when you do that, you have to keep in mind that this t is how long the freight train goes. And the passenger train goes an hour less, and so your answer, if you use these, will come out to 4. And then the passenger train is 1 hour less than that, so it'd be 3 hours. So it'd be the same answers we got. Last worded question. Soccer field dimensions. Width of a soccer is 35 yards less than the length. So if I draw a soccer field, I have the length, and then they say that the width is whatever that length is minus 35. And then they say the perimeter is 230. So I know the perimeter formula is 2 lengths plus 2 widths. And so the perimeter is 330 is equal to, now here's my length and here's my width. So I can plug those in. So 2 times L plus 2 times the width is L minus 35. Okay, using the distributive property again, I get 2L minus 70. 2L here is equal to 330. Collecting like terms, 4L minus 70 equals 330. And then I'll add 70 to both sides. So I'll have 400 is equal to 4L. And then divide both sides by 4. So the length must be equal to 100. In the question, they say, find the dimensions of the field. So I know that the length is 100. So therefore, the length is 100. So the width has got to be the length minus 35 or 65. Okay, so those would be my dimensions. Hopefully that helps you with those questions.